I'm Lana. I'm a PhD student at the Australian Institute for Machine Learning, and I'm not a typical example of a data scientist in my belief, but I'm certainly very happy to be considered and to be here and listening to a lot of really great female data scientists. So to say a little bit about me, I started off with a Bachelor of Psychology at Flinders University, and I did my honours in something called human factors, which I will get into in a second. So I definitely did not anticipate to be now at an Institute for Machine Learning. It's very unusual for me to come to terms with, but I'm certainly very happy that I ended up here through, I think, a series of happy accidents is probably the best way to describe that. So I'm doing an interdisciplinary PhD, and I'm sure a lot of people on this Zoom probably have done one or are doing one as well. I think that's the nature of data science. And I'm supervised by three absolutely phenomenal women who are respectively each at the top of their fields, in my opinion, but I am biased. But I just know that I'm very, very lucky to have their guidance. And so the first is Dr. Lauren Oakden-Rayner, and she is an AI safety researcher, specifically one of the only in the world who looks at AI safety for medicine. And she's also a radiologist and just is a bit of a wunderkind and can do everything. Professor Carolyn Semler, who is based at the School of Psychology, and she's a cognitive scientist and also does a lot with the data science department, and has taught me a lot about maths and modeling and is also phenomenal. And Dr. Melissa McCradden, who's a bioethicist. We recently got her from the Sick Kids Hospital in Toronto to come over here. And she's also invaluable to me as well. So broadly, I sort of do a combination of all three of their fields. So AI safety, cognitive science, which is where I started, and bioethics. So I'm really trying to get in the middle of that triangle in my work. And specifically, I look at medical AI for radiologists and what it might be doing to their decision-making. So just to make sure that everybody is aware, human factors is a multidisciplinary field that basically tries to analyze the human-machine relationship and look at how that interaction flows and the wider system in which it exists in, which we call a socio-technical system. So whenever technology is created, it is always created by humans, and it is almost always implemented into a system with humans and many other factors to be considered, which unfortunately are often not. We call this field also sometimes just human-computer interaction, or HCI, but that also has its own set of differences that I've definitely learnt in my PhD. Also cognitive science, I'm sure most of you are aware, but it is just a study of all the mental processes that we typically can't see that guide all of our behaviors. And I focus specifically on decision-making. And cognitive science at its core is an interdisciplinary feat. I personally have been using computational modeling. So that also involves some elements of computer science, and also elements from philosophy and neuroscience as well. So it's always an interdisciplinary field. And the last one is AI safety, and that's primarily what Lauren is an expert in, and that is essentially trying to prevent a lot of consequences that come from poor model development. And even in really good models, there, I'm sure as we all know, are a set of considerations and potential harms. And I really look at what that looks like when it gets to the human. And hopefully we can develop safeguards for errors and harms. This informs policy. We have a lot of guidelines, ways to conduct clinical trials. And that really is the goal, is we want to know where things might go wrong before they go wrong and be prepared for that to happen. As you can probably imagine, there's a lot of things right now in AI to consider. And I think just as a quick note, I know that AI safety gets a sometimes different reputation as being the study of how AI might become sentient and destroy us, or do a myriad of miraculous things that we should be very scared of. And I just want to say that that's not what I do, and it's not what I believe true AI safety is. And there are some really phenomenal, fantastic AI ethicists who discuss this problem, but I'm definitely not part of the doomerism camp, as it's called. And I think that there are a lot of harms that come from AI when you misrepresent what AI can and cannot do, rather than AI can do a bunch of things. So I guess what I'm most interested in is expert decision-making with AI. I absolutely love this quote from, I think, an IBM conference in the 70s that says, "A computer can never be held accountable. Therefore, a computer must never make a management decision." But I think it's really interesting how there are so many principles about design and technology from the 60s and 70s that I find really relevant today, and that I think we would be much better off if we had kind of kept instead with that sort of line of thinking. But essentially, I look at what happens to this internal and external environment that we know as, for example, the radiologist's world of expertise in their clinic. What are the things that inform their decision-making? How do they make their decisions? And where does AI fit into that? Because I know that there's a lot of lack of direction when we implement and create technologies, and a lot of really incorrect assumptions about human cognition, and definitely incorrect assumptions about how AI works and functions and what it should be for. And a lot of these assumptions have led to really bad design, sometimes very bad errors. And in an area such as medicine and clinical decision-making, you really want to be avoiding disasters at all costs. So in my PhD specifically, I work somewhat with a company called Annalise AI, and they have a comprehensive system for radiologists all across Australia, I think the UK and Singapore as well. And they definitely have what we would consider a really high standard product of AI. And it is currently being used in Australia in Dr. Jones and Partners and a bunch of other clinics. And although it is, from what I've seen and what I've been researching, a really good system in terms of many different factors, accuracy and the pathologies that it can detect, there is so much that we don't know, and there's so much to consider that just hasn't been considered. And I think the one thing that we can all agree on is that AI sort of just burst onto the scene in the public. And definitely, I think that is reflected in even how it's implemented. It just sort of gets out there, let's hope for the best. And if there are any errors, I guess we'll notice them in post. And I think we don't want to do that. We want to be a little bit more aware about what can happen and what we're exactly doing. And I guess in that way, I've entered a place that is filled with a lot of researchers who do research that is very different to me. They all have degrees in computer science, machine learning, and often have completely different methods of approaching a problem. And I think coming into that a little bit cold turkey was a very interesting experience for me. So I had a psychology degree, and that was, number one, primarily women. Number two, there was stats involved, but I would say they are very far away from the stats that I do now. And definitely data science, I think, could have been better taught for me in my undergrad, but I also didn't really think that I'd necessarily have to use it. I ended up doing my honors in human factors and thought, this is a really interesting problem. Like, how do people interact with automation and technology? And what are we doing wrong when we're creating technology? And I thought that that was a question that everybody wanted to answer, and it turns out it's not. And that actually a lot of people aren't aware that this field exists, and you do sort of have to push for it. And that is something definitely that I was not prepared for. And being interdisciplinary in the beginning can be very challenging, but I also think it's been incredibly rewarding. So as an I guess what I call myself many things. I call myself an AI safety researcher. I'm also a cognitive scientist. I often get called an ethicist because from my experience, when you're doing something in AI that's not just direct technical modeling, I just sort of almost get put into a box of being an ethicist because I look at human problems, which is definitely a compliment. I would love to have the skill set of like a formal ethicist, but I'm still getting there. And I also do try to understand machine learning. So as part of that, I think I've sort of been put in a position where suddenly I'm trying to be a data scientist. I'm learning data science. I'm surrounded by data scientists of some form. And yes, as I've said before, it was very daunting at first. But I've been learning a lot from really amazing people, and just like our other speakers have said before, by really amazing women. So my supervisory board is all female, which is actually exceedingly rare. I've noticed, especially in AI. And I think that that in of itself is very inspiring. They all have different fields and they all have different points of view, but they're all very unanimously toward a better future, and a better future with technology, and a more inclusive future as well. So my supervisors have definitely been very helpful in that sense of, well, we want you to be a data scientist. We want you to do all these things, learn how to code, get some understanding about deep learning, AI. And what I do primarily, and what I have just done, is some computational modeling using formal models of human cognition to a data set of use of AI by radiologists. So that took me around a year to do, and it was very challenging in many ways. But I think, and this sort of flows on to this discussion about data science and the slide that I have, having support from other people has been really important. So I primarily sort of got help from other students and other PhD students and colleagues of mine. And I think the key thing with being in an institute for machine learning is that they're all very proficient in coding. A lot of them do deep learning, and they do statistics in some shape or form. But interestingly enough, the problems that I have been a little bit more challenging, and for me, but not so much for them. So it's very easy for them to help me out with simple code and debugging. Having that room to fail has definitely been key to my success, and being able to get them to allow me to make mistakes. And I think, as just a final point about being a woman in STEM and our way forward, is just acknowledging that, and what I've found the most is that our data collection, our data itself, and our modeling always reflects ourselves and our biases. And so diversity is definitely the key to better science. Right, thank you.